My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 212. In this lecture, we will try to understand projection. Basically, there are two types of projections. First one is scalar projection. Second one is vector projection. Isn't it? Now, let me assume I have a vector A bar and a vector B bar. Let me say this is vector A bar and this is vector B bar. Just try to recall dot product which I discussed in previous lectures. A bar dot B bar equal to mod of A bar into mod of B bar cos theta. You can say magnitude, that's length, mod A bar into mod B bar into cos theta. I want you to think of projection as shadow. This one must understand. You can think projection as a shadow. This point is very important. Projection is, you can think of like a shadow. Let me assume sun rays. These are the sun rays. Sun rays coming down. If I project vector A bar onto B bar, then I would have shadow that would fall. It's going to come down perpendicular from this tip, perpendicular from this particular point. From the tip of this arrow up, a little tip, I must draw a perpendicular, isn't it? I can say projection, I can say like this, projection of a vector A bar onto a vector B bar is nothing but you take this vector A bar and make a perpendicular fall on B. Just let me show this one. This is a perpendicular which I am drawing this tip of from this particular point. Just draw this perpendicular. We are measuring a shadow, isn't it? We are measuring a shadow, and there is no arrow on the end of this. This is shadow. I can say this one is shadow. This part is shadow till this part, isn't it? Let me repeat, we are measuring a shadow and there is no arrow on the end of this. The reason there is no arrow because it's a scalar. It's a value. This is just, it's a value. This part, it's a value. Isn't it? It's a value. I can say it's a value, or I can say it's a scalar. I can say it's a scalar. Just length. I can say it's just length. Therefore, this projection is known as scalar projection. Anyway, we will try to differentiate scalar projections and vector projection with some numerical example. Time being, let me proceed further. If I do a vector, let me say like this. This is one case. There is another case. If I do a vector that is perpendicular to another vector. Let me say this is my A bar, isn't it? This is A bar and this is my B bar. These two vectors are perpendiculars, isn't it? If I do a vector that is perpendicular to another vector and I saw the shine, the sun from, I can say your sun rays are falling like this, isn't it? In this direction. I can say the shine, the sun from above like this, that you would see, or even if I went this way, if I went this way also, even if I went this way, you would see that there is not going to be any shadow. There is not, I will write otherwise, there is not going to be any shadow. There is not going to be any shadow. So there is no shadow. In this case, one must understand there is no shadow. This is no shadow case. There is no shadow. And again, this was one of the properties that we talked about of the dot product. I already discussed this one, dot product. What's this property? When can I say if the dot product is 0? Can I say like this? I already discussed this one. If the dot product is 0, if the dot product is 0, yes, if the dot product is 0, then the two vectors are perpendicular. Then I can say A bar and B bar are perpendicular. So no vector projection. There is no vector projection in the no vector projection. You cannot project it, isn't it? No vector projection when we have sun straight over our heads. You probably know that. And finally, if we have an obtuse angle case, this is obtuse angle case. What is your obtuse angle? That must be less than 90 degrees. I must say it, sorry. It must be obtuse angle means it must be greater than 90 degrees and less than 180 degrees. Then I can say that angle is known as obtuse angle. Therefore, let me say this is your what we are going to have. I am going to project. How can I project? If I am, let me say this is my A bar and this is my B bar. Now, if I want to project, what I have to do? Just assume your sunshine or sun rays, they are falling like this. Then what happens? I must see the shadow. If you want to see the shadow, what you have to do? Just you must extend this vector B bar like this, so that I can say like this. So it is really does not matter how long B is, we are going to make as long as we want it to be, because we need to know where this shadow is going to land. I need this shadow, where this shadow is going to land. That's why just I am extending this vector like this, so that now I can measure. How can I do it? Just see. Again, same story. What I have to do? It is simple. Again, I will repeat. Let me assume these are sun rays which are falling like this. Now I need projection of A bar on B bar. Means projection of A bar means I need shadow of A bar on B bar. In that case, what I have to do? Just I must extend this line to whichever length you want. Just keep on stretching this line like this, and now you can find shadow of A bar on B bar. How can I find? Same story. How will it be? Just write a perpendicular like this. Now you can find this shadow. This shadow. This I can say. This is shadow. This one is shadow, isn't it? This one is shadow. This one is projection, isn't it? This one is projection. This magnitude is scalar. Then if you specify direction, that will become vector projection. This magnitude, just if you consider this magnitude, I can say it's a scalar projection. If you specify direction in which this scalar is, I can say that that's vector projection. At this point of time, you need not worry about whether it is vector projection or scalar projection. We will try to understand in detailed manner with proper examples. Timing, just assume that this is my A bar and this is my B bar. This one is the projection. You are projecting A bar onto B bar. Now, how to find scalar projection? So if I have vector A bar and vector B bar, we call this, let me say origin O, isn't it? We want to look at how this is projected, and again we are going to draw a nice what can I draw? A nice this let me say, as usual, let me say this one is A bar and this one is B bar. I must draw a perpendicular. We are going to draw a nice perpendicular line. This is nice perpendicular line. So you are going to draw a perpendicular line from the head of the vector. This is head of the vector, isn't it? that being projected from the head of the vector, that being projected, and this is going to be A bar, projection of A bar on B bar. This is projection of A bar on B bar. So vector A bar is being projected. I can say vector A bar is being projected. Vector A bar is being projected onto B bar. Vector A bar is being projected onto B bar. Can I say like this? Yes. Now let me assume this is O, let me assume this is N, isn't it? Let me assume this is N and this angle is theta. Now here what will I do? What is my cos theta? My cos theta, by the definition of the cos theta, this is adjacent side by hypotenuse, adjacent side by hypotenuse, isn't it? What is my adjacent side? My adjacent side is ON. And what is my hypotenuse? I can say my hypotenuse is A bar. Can I say modulus of A bar? What is this? Cos theta equal to. Now if I cross multiply it, what will I get? ON. That is, this is projection. This is scalar projection. I can say this one is scalar projection. Scalar projection ON equal to mod of A bar into cos theta, isn't it? Let me assume this is equation 1. But we know from the equation for the product, I can say dot product. How can I define dot product? A bar dot B bar equal to modulus of A bar into modulus of B bar into cos theta. This is definition of your dot product. You can see I can write this, let me say, in the place of let me say like this, in the place of mod A bar into cos theta. In the place of mod A bar into cos theta, what can I write? Which one can I write? Just say this one. It is simple. A bar dot B bar equal to, in the place of mod A bar into cos theta, I can write, can I write something like I can write ON. Otherwise, if you want to divide, otherwise you can divide with, of course, I can write ON. Can I write ON? Isn't it? ON into, what can I write? ON into mod B bar. Can I write like this? Yes. From this, what will I write? What is my ON? My ON is A bar dot B bar by mod B bar. Can I write like this? Yes. What is this? This ON is scalar projection. This projection, you are projecting, scalar projection. You are projecting, this is scalar projection. You are projecting A bar onto B bar. That is essentially scalar projection. Let me say this is number 2, equation 2, isn't it? ON is scalar projection. I can say like this. I could write 2 different equations for the projection of A. I am writing 2 different equations. This is first equation. This is second one. There are 2 forms. I can say there are 2 forms. I could write 2 different forms for the projection of A bar on B bar depending on what I have to work with. We will try to understand these things with some numerical example. My 2 equations are these 2 forms here for the projection of A bar. These are for projection of A bar on B bar. That you must understand. This is projection of A bar. Whose projection? Projection of A bar on B bar. we have two different forms. One is On equal to mod A bar cos theta, and another one is On equal to A bar dot B bar by mod A bar. This is projection of A on B bar. These two forms are important. How these two forms are useful, we will try to understand the scalar projection first with a numerical example, so that we will try to analyze, we will try to understand after that vector projection. Just let me assume here I have two vectors. Let me say this is mod u bar, means length of this vector is, I am assuming it's 4. And again, I am assuming there is another vector mod v bar which is equal to 1. This length of this vector is 1. Now, I am interested, projection of u. I have to project what I need. Projection of u bar on v bar. That I need, isn't it? How can I do it? As I have to project u on v, I must extend this v bar. How can I extend? Just say, let me extend this like this. Just I am extending, isn't it? After extending, I must find what I have to find. As I told you, what is this first one? This one is mod u bar equal to 4. Let me say this mod v bar equal to 1. We are projecting u on v. In that case, just extend, so that I need shadow. Therefore, just I am extending v, and just let me write a perpendicular. Just if I write perpendicular, I will get, what will I get? I will get the shadow. How can I calculate projection of u? Project of u. Can I say something? This is the projection of u. Projection of u on v. There are two forms which we discussed in previous slide. How can I write? I can write which is equal to mod projection of u on v means what? Mod u bar cos theta. Let me assume it's given angle is 20 degrees. In question itself it's given. In question what they are giving? Mod u equal to 4 and mod v equal to 1. And angle between these two vectors is theta. Then I have to find projection of u on v. Just I am extending v and taking perpendicular. Then I can calculate this projection by using a formula. I already discussed mod u bar cos theta. What is the length of mod u? That is 4. Cos theta means cos 20 degrees. Just go to trigonometric table. Just if you find, you will get 3.76. This is one simple example. I can say it is geometric form. I can say this is this projection. This is, of course, which type of projection? This is scalar projection. This is scalar projection. How do you know whether it is scalar projection or not? This 3.76 is scalar projection, isn't it? This is scalar value, but scalar projection under geometric form. I can say this formula mod u bar cos theta comes under geometric form. We will try to understand with one more simple example. How will it be? Just say this one. Let me assume. Let me say like this. How can I say? I have. Let me say like this. I have this vector mod p bar equal to 2 and mod q bar equal to, this is mod q bar equal to 4. I need, this is p, this one is p, this one is q. I need what? I need projection of p. I need projection of p on q. I need projection of p on q. Therefore, projection of p on q means what I have to do? Just see what I have to do. Just I must draw a perpendicular, isn't it? This is p, this is p, isn't it? This is p, this is q, isn't it? I have to project this one. In that case, I must extend this vector like this to whichever length you want. Now, just take perpendicular like this. Just I am taking perpendicular. Now, what is this angle? This angle, it's given 120 degrees. In question, they have given, in question, let me write question otherwise. Our question is, it's given that mod p bar equal to 2 and mod q bar equal to 4. Now you have to find projection of p on q and angle between p and q. Angle between p and q is It's 120 degrees. This is given information. Now I have to find projection of P on Q as according to your geometric form. Projection of P bar on Q bar, I can write it as mod P bar into cos theta. My cos theta is 120. What is my mod P bar? Mod P bar is 2. Cos 120 means cos 90 plus 30 minus sin 30. That is essentially minus 1 by 2. That is minus 1. This is also, this is scalar. This is scalar. Therefore, this is known as, this is scalar. This is known as scalar projection, I can say. This is scalar projection, isn't it? Now, anyway, we will try to understand vector projection also. Before going to discuss what is vector projection, let me spend few seconds on again scalar projection. Let me say I have a point here. What is my first point? Let me assume like this. What is this? This is 2 comma 4. This is 2 comma 4. Let me say this 2 comma 4 is a bar. Let me say this is a bar. This vector is a bar, isn't it? Let me say this is 6 comma 1. This is 6 comma 1. This vector is known as b bar, isn't it? Now what I have to do? I need projection of A on B means what I have to do? Start from tip of A bar. This is A bar, tip of A bar, and I have to draw perpendicular. Isn't it? Just see, I am drawing a perpendicular. How am I drawing this perpendicular? Start from tip of the A bar, draw this perpendicular. This is perpendicular. Now, how can I find? There is 2, 4 and 6, 1. How can I find? I need projection. This is my what I need, this projection of A bar on B bar. How can I find? What is the formula? I already discussed. A bar dot, this is something like earlier one geometric form. This I can treat it as algebraic form, isn't it? In earlier case, angle is given. No, there is no angle. In that case, what is the formula? Projection of A on B bar is A bar dot B bar by mod B bar. What is my A bar dot B bar? What does it mean? That is 2 into 6, isn't it? That is 2 into 6 plus 4 into 1, isn't it? By mod B bar means under root of 6 square plus 1 square, that is 2 6 are 12 plus 4 by under root 37, isn't it? 16 by root 37. Therefore, what value will you get? You will get 2.6. This is again scalar projection, is it not? This length, this projection, this is just see, this is almost 2.6, this length, almost 2.6, isn't it? This is the projection 2.6, isn't it? That you can understand, certainly one can understand. Now we will try to understand vector projection first, then we will try to solve one simple problem on vector projection. To go from, our intention is, let me write, to go from a scalar projection, to go from a scalar projection to a vector projection, to go from scalar projection to vector projection, we will multiply, this point is important, we will multiply. What will you multiply? We will multiply by the unit vector, in the direction of B bar, in the direction, that is where the shadow is. Isn't it? This is where the shadow is going to display, fall, where the shadow is going to fall. We will try to understand. Vector projection have direction. I can say vector projection, this point I can write vector projection have direction. Vector projection have direction. This point is important. vector projection have direction, and therefore I must we will try to understand again how will it be. Just as usual, let me assume this is my A bar, this is my vector. Otherwise, let me erase this first. Yes, let me write this is my A bar, isn't it? This is my B bar. This must be angle theta, isn't it? I need projection of A, projection, vector projection. If you speak strictly, what type of projection is? Vector projection of A bar on B bar. I need that one. Is equal to A bar dot B bar by mod B bar into, I can say, B bar by mod B bar. B bar by mod B bar. This entire thing is known as vector projection of A bar on B bar, isn't it? If you observe carefully, what is this? What is this part? This part is scalar projection. I can say it is scalar. You are multiplying your scalar projection with what? This is unit vector. This is unit vector. Means if you multiply, you are projecting A on B, means I must take this one, and I must take scalar projection on which you are going to project. You are going to project your shadow on B bar. I must take unit vector, means vector by its magnitude, isn't it? This entire thing is known as vector projection. So we will try to understand this with as usual. This you know what is this particular thing. This magnitude. This magnitude is this one. A bar dot B bar by mod B bar, isn't it? This part is A bar dot B bar by mod B bar. In order to get that vector projection, as I told you, you have to multiply with the unit vector on which your shadow is going to on which your shadow is going to display. Anyway, it is simple and straightforward. Let me explain this with the help of one simple numerical problem, so that you can understand this in detailed manner. Let me assume what I have here. Just see this one. I need, what is my U here? Just see. My U here, let me say, otherwise, I need, let me say, A. A is my vector, this is A bar. And another vector, this is B bar. I need projection of A on B, isn't it? I need projection of A bar on B bar. Therefore, how can I find projection of A bar on B bar? Therefore, this is B bar, therefore just I am extending this like this, isn't it? After that, what I have to do? I must draw a perpendicular, isn't it? I must draw perpendicular. Therefore, this one is, what is this? This one is, I can say, this is shadow. I need vector projection. How can I calculate that vector projection? It is simple and straightforward, which is equal to, what is my formula? I must calculate. First, let me calculate. Let me calculate what is this scalar projection. How can I calculate scalar projection? A bar dot B bar by mod B bar. That's formula. First, let me calculate scalar projection of A bar dot B bar by mod B bar. This is scalar projection. What is my A bar? Minus 4 into 4. Minus 4 into 4. This is dot product, and 1 into 3. Let me say this is 1 into 3. By mod B bar means what? Under root of 4 square plus 3 square. Therefore, minus 16 plus 3 by root 25 means 5. That what will you get? 3 minus 16 means that is minus 13 by 5. This is scalar projection. But what I need? I need vector projection. How can I calculate vector projection? As I told you, you have to multiply with unit vector. This is minus 13 by 5 is scalar projection. It must be multiplied by what? We have to multiply with it by unit vector. How can I, you are projecting A on B. This is A, this is B. For this B, how can I find unit vector? That is B bar by mod B bar. That is B bar by mod B bar means I can say it is 4 comma 3 by modulus means under root of 4 square plus 3 square 16 plus 9. I think it must be root 25 means I can say 5. Therefore, vector projection is scalar into this unit vector. Unit vector means I can write 4 3 by 5. Therefore, what can I write? If you multiply this one, what will you get? Which vector will you get? You will get minus 52 by 25 minus 39 by 25. This is my vector projection. What is my scalar projection? My scalar projection is minus 13.5. This is 0. Just see, negative side. You are moving this particular side, isn't it? It is maybe 5 3 ja means I think 2 point minus 2 point something you will get. That's what this length. Just see this length. What's the minus 13? 5 2 ja 10. 2.6 minus 2.6 maybe. This is almost minus 2.6 on this length. This is almost minus. This length is minus 13 by 5. And if you need vector, just multiply with the unit vector. Whose unit vector? B's unit vector. Now just draw this vector. You can understand what is this vector projection. Certainly one can understand, one can differentiate between vector projection and scalar projection. Just go through this lecture. If you have any difficulty, just keep a comment so that we will try to understand. Thank you very much.